The lesson topic for this video is, I can factor out the GCF and factor a quadratic expression when a equals 1. Now what this lesson is a quick but important review of some factoring skills you need to have before we enter our next chapter of study. So make sure you go through these and remind yourself how to perform each factoring task. So first of all, just GCF work here. Remember that anytime you start working with a quadratic or a polynomial of any degree, you want to first look for a greatest common factor. If you don't look for that greatest common factor at first, the problem actually is sometimes unfactorable, and then also sometimes the problem becomes more difficult if you do not factor that out first. So always look at not only the number, but the variable part of each term to see if there's a common factor. You'll notice with 5 and 15 there's a common factor of 5, and we have x to the third here, which is x times x times x, and this is an x here. So the greatest common factor for this expression is 5 and an x. Again, we can't take out more than one x because this term here only has one of them. So then we talk about what's left then in the parentheses. If I factor out 5x, in this term here there will be x squared remaining, plus here we have 15x, we've factored out the 5, so we have 3 left, and if we factored out the x, we have no x's left at all, so we have a 3 left here. Alright, so that is simplified, or the greatest common factor is factored out. The second one, 2x squared minus 2x, notice they both have a 2 in common, a factor of 2, and they also both have a common factor of x. This one I put in here to be careful. Notice that 2x will be factored out, and this term here is 2x. Be careful with that. So when we factor out 2x out of here, we're left with just one x left and a minus sign. And then when we have 2x and we factor out all of that, don't forget that we need to put a 1 in the parentheses there, because if we started with 2 terms in our original expression, the parentheses must end up with 2 terms, so that if we distributed the 2x back in, we would end up with 2 terms. If we hadn't put this here at all, then we would only have 1 term in our final answer. Alright, and the third one here, 7x squared plus 10x. Notice that 7 and 10 do not have a common factor. All we can factor out here is an x. So that's just a really quick review of factoring out a GCF. And we'll go on next slide to what happens when you have a quadratic expression when a equals 1. Okay, so remember there's a difference when the leading coefficient, which we call a, the coefficient of the x squared term, is a 1 or is something other than 1. When a equals 1, there's actually a very quick method of factoring, and if it is factorable, all you would need to do is have 2 sets of parentheses right below the expression, and it would be factorable in just one step. Alright, so that step, if you remember, you take the c term and you think of all the factors of the c term, and I just like to list them out right when I'm reviewing my steps for this so I don't forget the process. So 1 times 15 is 15, and 3 times 5 is 15. So those are the only options that we have. Then what we have to ask ourselves is which of these factor pairs adds up to the middle term, which we call b, right? The middle term here, which is b. And you have to look at the sign in front of it as well. So we need to add up to positive 8. Well, 3 plus 5 is, in fact, 8. So we know that 3 and 5 are the factors we're going to use. And so we can simply put an x in each set of parentheses. And then they're both positive, so plus 3 and a plus 5. Again, if we FOILed this or multiplied the first terms, the outside terms, the inside terms, and the last terms, we would end up with what we began with. So x squared plus 5x plus 3x, that adds up to 8x, and plus 15. So this is factored right there. So it's a pretty quick process. Again, let's try some more. Here's negative 27 as our c term. Again, a is 1. We notice that right away. Negative 27, well, 1 times 27 is 27, but one of them needs to be negative. 3 times 9 is 27, but one of them needs to be negative. And those are the only factors of negative 27, unless I just switch the minus sign around to the other term. When we add these, we get 26. All right, and when we add these, we get 6. Notice 6 is close to the number we need, but we need -6. At that point, you should go, oh, that's right, we got to switch this 3 to a +3 and then -9, or then make the 9 negative, which will add up to -6 then, which is what we needed. So we can now put our factors down. We put our x here and here, and we need a +3 and a -9. And again, you can always FOIL to check to make sure you have the right factors. Okay, and so the next one here, this is supposed to be a 28, not a 14. Sorry about that. All right, so we're going to write -28 off to the side, and we're going to come up with the factors of -28. 1 times 28, one of them needs to be negative. 2 times 14, but one of them needs to be negative. And 4 times 7, but one of them needs to be negative. We notice that these two terms right here add up to our middle term of 12, +12, so we have our factors. X and x -2 and +14. And our last one, go ahead and work ahead on this if you'd like to double check your factoring skills. +24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. And what we have to realize here is when we add up all of these terms, we get, well, 25 or 14 or 11 or 10. And 10 looks good, except for we need that 10 to be -10. So this reminds us that a negative times a negative is also +24. A negative times a negative will give us that -10. It is not going to be 2 times -12. Okay, that's not going to work if you chose that, because that means you're multiplying a +2 times a -12 to get our original C term, which would need to be -24, and it is not. So we do have to get the correct factors here of -4 and -6. So x minus 4, x minus 6, and we're good to go. And one last thing I want to remind you of in this lesson, and then we'll be done with the review, is that we have a difference of two squares situation sometimes. Difference of two perfect squares. Okay, 81 is a perfect square because it is 9 times 9. 1 in front here is 1 times 1. This 4 is 2 times 2, and this 36 is 6 times 6. All of these numbers are perfect squares. But let's be careful with that second one, and I'll show you why. So a difference of two squares can be factored quickly into an x plus something and an x minus something. And since the 81 is 9 times 9, those two factors are 9 and 9. Again, if we check this by FOIL, we'd get x squared minus 9x plus 9x, which gives us no middle term here, which we do not have, and then minus 81. Now this next one, you might think to use difference of squares right away, but you shouldn't. Because like we said on the very first slide, we always look first for a GCF. Although this is factorable using the difference of two squares, we should first take out a 4, and we're left with x squared minus 9. At this point, this is still a difference of squares, and we would factor that down into two sets of parentheses, leaving the 4 out front, and we know will be an x here and an x here. 9 is 3 times 3, so we put a 3 here and a 3 here. One needs to be positive and one needs to be negative. Had you not taken out that GCF at the beginning, you would have 2x plus 6 and 2x minus 6. And in both of those situations, we have a GCF that we haven't taken out. A 2 from here and a 2 from here. So we'd have to factor both of those 2's out, which will still get us to this final answer because both 2's factored out would be a 4, and then each of the parentheses would be x plus 3 and x minus 3. So quicker to take that GCF out first.